Alpha decay. In this video, we'll define alpha decay and review what an alpha particle is. We'll determine what's left over after alpha decay and talk about a couple of applications, specifically how alpha decay is used in smoke detectors and how we get mineable helium from alpha decay. In alpha decay, a nuclei loses an alpha particle. This is generally restricted to heavier elements. It occurs when a neutron to proton ratio is too large. Let's remember what an alpha particle is. An alpha particle is effectively a helium atom. We can even write it with the symbol for helium. It has a mass unit of 4 and a proton number of 2. It's useful to keep this 2,4 listed, even though you don't have to, in order to balance nuclear reactions. Let's look at an example. If we take uranium-238, something that typically undergoes alpha decay, and we look at what is left over after we remove a helium, we'll see that there must be 234 as our mass unit. We get this from 238 minus 4, and there must be 90 as its protons. We get that from 92 minus 2. And so we know that when uranium-238 undergoes alpha decay, we're left with 234 and 90 as our mass and proton numbers respectively. We can then go to the periodic table, find atomic number 90, and see what it is, and it's thorium. And so we must have thorium there. Let's do a few examples where we don't have the answer sitting in front of us as we do it. If I tell you that americinium undergoes alpha decay, we can look at this and we can say, okay, well, first off, I need 241 minus 4, and that's going to give me my mass number. That leaves me with 237. I can then take 95 minus 2 to get my number of protons, which is 93. At this point, I go to the periodic table and I find the proton number 93, and I see that that is NP. Let's do one more example. This time, I ask you to write the full equation for the alpha decay of cesium-263. Now, notice here, I give you the name. The name of the element tells you the proton number once you look at the periodic table. So we know that the mass is going to be 263, and by using the periodic table, we can find that the proton number is 106. From here, we know that it undergoes alpha decay, and so we're going to have a 4 mass unit, 2 proton helium atom coming off, and then we see what's left over. We take our 263 mass number, we subtract our 4 from it to give us 259. We take our 106 proton number, subtract our 2, and we get 104. We then go to the periodic table and find that the atom with a Z of 104 is RF. And we have completed our equation. Now let's talk about a couple of places that we see alpha decay around us. The first one that I've picked, just mainly because I think it's kind of interesting, is how fire detectors work. We actually put american-241, and you might notice that americinium is the example that we actually used in the last slides. It decays via alpha decay, and it ionizes the surrounding air. When that happens, we actually complete a circuit from the battery to this plane. So you'll set up americinium here, and by you, I mean the fire detector creators. This ionizes the air, and having this ionized air in here allows a complete circuit from here to here. Without that ionized air, there's no circuit. What happens then is when smoke comes in, it lessens the ionization of the air because it gets in the way. Now this americinium's radiation can't ionize the air, and this circuit is no longer complete. When that circuit is no longer complete, that trips something in the system that signals an alarm. And that's how smoke can cause an alarm sound in this system. Another place that we use this is actually naturally occurring alpha decay in the ground. There's areas of the world that have large uranium and thorium deposits, and these large uranium and thorium deposits naturally undergo alpha decay. When they undergo alpha decay, the helium actually ends up stuck in the ground effectively. And this is what actually allows us to get helium because we mine it out of the ground, which may seem weird considering that it is a gas. However, this is actually where we get most of our helium from. As a side note, it actually turns out that this is a limited resource for us because most of what we get our helium from is this radioactive decay process. And we use helium for a lot of things. This isn't just a party balloon fun thing. We use it for instance, keeping supercooled magnets cool. And you might say, that's fine. I don't need supercooled magnets. But there's a lot of science research that does, and also your MRIs use it. There's several other places that it's used too. It's just interesting to note that helium is a limited resource that we could one day run out of. As review, alpha decay occurs when a heavy atom loses a particle which has 2 neutrons and 2 protons from its nucleus. We can balance the neutrons and charges to find out what particle is left over. There are many places that alpha decay occurs around us, but the 2 that we talked about are in smoke detectors and occurring in the ground, allowing us to actually mine helium.